Hello, hello, and welcome to a special edition live stream. Usually I do these on Tuesday nights at 8 o'clock. I decided to run a special edition this Friday. Yeah. So that got monitors set up. Hang on, let me get rid of the echo. There we go. Beautiful. So I decided because I got a lot of questions from a students on a midterm exam that I set up for a control system design course on how exactly to go about um, doing said midterm. So really the point of the midterm was never to sort of trick anybody. It's to get students to draw a complete set of schematics. Um, so I don't feel that sort of walking through like my approach to it is giving away anything or cutting into sort of the objectives of that. And I thought it might be helpful. And again, I like to treat my live stream stuff as sort of a walking through my thought process, and this sort of fits that. So I'm going to walk through my approach to the midterm exam. Now it's cheating a little bit in that I wrote the thing, right? Cool part is though, I write these so far in advance that I don't actually remember everything it says. So for this midterm exam, we need a complete schematic sheet set for the machine described below. And I know here to sort of ease students' mind that we have programming tasks in here. We're not programming this. This is strictly a wiring exercise. So creating the schematics. So as we scroll down, we're doing an automatic case packer. It's designed to count and box a product, 50 parts per box. We don't care about that as the electricians or the designers of the control system. We don't care. That's a programming problem. We're not going to do a single thing in this sort of project for this deliverable to do anything to do with 50 parts. We need the capability to count, but that's really a programmer's problem, right? Along with this operational sequence. This is here because as sort of a statement of work, a designer would get an operational sequence. Like, how are we going to go about, actually achieving the end result of this machine? So, what really matters to me right now the most is sort of the IO summary. And this is telling us what input, what output goes on what input or output point. And I keep fiddling with the volume on my headphones just because I want to make sure that I can still be heard. I did do a live stream on Tuesday, like normal, or at least I attempted. Like I sat here, I did some on-shape design for 2 hours, and then realized that it never went live for various reasons. So I'm a little paranoid. Like I've got it up on YouTube on another monitor to make sure that it's actually streaming. The monitor's on, so I can at least hear myself. It's delayed through YouTube, so it's kind of weird. It forces me to slow down if I can hear myself. So I'll check in once in a while. But anyway, the IO summary matters because it's going to tell me what to put where on what input and what output. Let's see. Professionals, so our deliverables. We must create a complete drawing set for this, and this is the PLC model we will be using. That it's sort of based around, excluding a 2D cabinet layout. And the reason for that is, as of the midterm, we have not actually covered 2D cabinet layouts. I think I mentioned in one of the videos, not in a live stream, but in one of the posted videos on this channel, how like the basics, the very basics of like a 2D footprint for a single component. I don't want to do the full layout um, yet. So, but as part of our sheet set, we need a title block and a document index. We need power distribution, the PLC wiring, and bill of materials. Cool part is item number one and item number four are like almost entirely automatic. They just are. So we're really, I mean, primarily concerned with creating item number two, which includes the main power and the control power. And I mentioned in one of the SolidWorks electrical videos that I've posted that's typically how I break things up anyway, right? Main power coming in, break it out to like 24-volt power on a different page. Um, and then PLC wiring, I don't know yet until we get in and start drawing, sort of what pages these will be. But yeah, let's see. Bill of materials again. That's going to be pretty automatic. And then verified bond. Now, keyword here, and again, this is me cheating because I wrote it. I was hoping it would be clear enough. Um, and this is part of what scared some of the students is the keyword here is representative. So I created a list, or more specific, let's be honest, I had Gemini create a list of acceptable part numbers for each of these functions. Because again, the goal of this exercise is to have the students create a schematic set, not spend hours shopping for appropriate part numbers to do the job we need to do. So sort of the goal. So I gave acceptable part numbers that we can use. We're not limited to that. That's important. We are going to use like this PLC. We are going to use these IO modules. Um, uh, Beyond that, like I got to be honest, I don't use a ton of Allen-Bradley proxies or Allen-Bradley screw beams, but that's what Gemini was sort of fixated on. If I have them, because I downloaded a lot of Allen Bradley parts as part of the video on downloading and installing manufacturer part databases, I have a lot of Allen Bradley. So if I have these, I'll use them. I mean, why not? We've also got outputs here, solenoid valves. Now it says SMC. I got to be honest, that does not look like an SMC part number to me. We might go shopping for that one. We need a motor contactor. I have no idea if that's an appropriate contactor. I trusted sort of Gemini. I'll be frank. So again, this bill of materials was not a intended to be a thou shall use these parts so much as it was here are parts that should work so you don't have to spend hours shopping, because the idea of this entire midterm, this exam, this exercise is to create demand, not waste all our time finding appropriate parts. So, and then just design guidance I'll be looking for. Make sure now in the BOM, this should read, and I'll probably edit it for future versions of this. The BOM in the sheet set needs to match what these things are labeled on the drawing, which honestly it will. Like this is automatic. This is automatic. We can't. As far as I know, I can't even force SolidWorks Electrical to mismatch the BOM in the drawings. Like it gets the tags from the drawings. So physical IO points. Yep. I mean, yes, that's a thing that's going to happen when we create our schematics. The power circuit, we will do that. Yep. And then the motor starter. So cool. Overload relay. I'll have to check and see if this has got an overload on it. It should, if that's a motor starter. I don't know though. I'm not intimately familiar with Allen-Bradley contactors. So that's the gist of where we're going. I already have SolidWorks Electrical open because I wanted to avoid the sort of loading screen live on stream. I'm just going to create a new project. We are going to use the ANSI template because on this install, I haven't created my own template. So contract number, well, let's go with, first of all, title. And this course is MAT 4310, and we'll call it midterm. That's the project, right? Customer is going to be, I'm just going to throw in Baker College and our address at the Cadillac campus. Again, I'm a fan, and I've mentioned this in sort of previous videos. I'm a fan of anywhere a piece of software lets me enter comments and things is good. So Baker College, Cadillac, Michigan. Yes, design office. That's where I would throw my name. And address is sort of optional. I mean, if I were doing this as a company, I would throw my company's address in there. But description, what did we actually call it? Automatic packing conveyor, something to do like that, right? I would call it this automated case packer. So we'll copy that and just throw it right in there as the description. Instead of ANSI project template, now we have an automatic case packer. Okay. A couple of seconds of thinking, and we should end up with the default document book here. And we do. So cover page, again, that's one of the deliverables. It's done. It's automatic. The drawing list is done. It's automatic. Now, as we add, we will need to update this, but that is a single click. That's important. So it's automatic. The drawing list is done for us. It's in our deliverables, but it is entirely automatic. The line diagram. Now, the deliverables, I mean, somewhere in here it did say that it wanted a one line diagram. For this machine, and I'm perfectly happy with this as sort of, the instructor, and if I were even accepting this from a builder, in this case, I would be perfectly happy deleting this entirely. For my use, I get the most use out of line diagrams for Ethernet. And we don't have any here. Like the PLC is capable, but we don't have any. This machine is so simple. We don't have any like Ethernet to an HMI, Ethernet to sensors, Ethernet to remote valve blocks, that kind of thing. So it'll probably be toward the end, but I may just get rid of this line diagram. It may just disappear, and that's fine. That's perfectly acceptable. So I'm going to go ahead and close it. Power we're going to need, but I'm going to rename it because we need properties. I'm going to rename it because we need main power and we need control power. So main power, okay, and open it. I didn't actually open it. I'm going to change the format because I like to work. Change the title block, replace. I like to work on this B with two columns for most of my drawings. So I'm going to select that. It's going to ask me, do I want to change it on just this drawing or all of these drawings in this project? So right now I want to, well, let's do it incorrectly. I'm going to click identical. Yes, yeah, fine. Um Problem with doing identical. If I go back to some of these, like my drawings list, it updated this one because originally this drawing was using that title block. I don't want that. This does not look good. This is not professional. So title block, replace, easy to fix. B without column. Select. This time I'm just going to change this selected one. Then boom, I'm back to a clean line diagram. It changed too, but honestly, like I said, I think this is going to end up just getting deleted. So for now, I'm not going to change it back since I'm going to be deleting it anyway. And it should have changed control as well. Cool. And actually, I'm going to change the properties on this. We might as well make this our control power drawing. So let's start with main power. That's usually a logical place to start. So main power. It says, if we look at our description, that we have, where did it go? Somewhere it specifically said that we were controlling a three-phase motor. Somewhere it said that that was a three-phase motor. I could do a search, but I don't want to do a search. Also, on purpose, I have our canvas in student view so that I don't do something dumb, accidentally click on grades or something. And, that would be a violation of federal law. That would be bad, especially since this is live on YouTube. Um, Honestly, somewhere in here, I saw a three-phase motor. Protection for motor contactor, three-phase right there. It says so somewhere else too that the motor itself is three-phase. I was hoping I could find that, but I'm not going to waste a bunch of time looking for it. It says it in here if we read it more carefully. But I've been thinking about talking through it and everything else. I'm not actually motor contactor first that time pushing it somewhere. It said specifically it was a three-phase motor. So we're going to go with three-phase motor. So three-phase coming in, draw a single wire. I am grab this one L1, L2 wire select because automatically this has five possible wires in it. The three phases and ground and neutral. Now, for usually, I mean, in an application like this, we're probably not going to end up with a neutral or the protection on this, but I mean, that's there for me. So I'll go ahead and click, and I'm not dragging just one click to start the wire, one click to end. I like to use my crosshair and line up. I have found that lining up the crosshair with sort of the first and last hex leaves me room so that if I draw another wire here on the other side, like I'm lining up with the first hex, and this one is actually snapping to the top of this wire. And if I space it out by a cursor, oops, I had the wrong thing selected. Draw a single wire. Yep, it switched back to 12 volts. So we need to select the right wire. Select. We still got our three phase. Again, lining up there, sort of a cursor away. I have found that when I need to cross reference, which is like the first thing I'm going to do, um, it leaves room for expansion. Like if I need to add more, if the side gets full and I add three-phase stuff over here, I have room now. So I'm going to cross-reference, which is origin destination. I'm going to make sure my symbols are the octagons that I like, which are these guys, and also the destination as the octagon, that guy. And when I do a single insert, I have found that sort of lining up with this hex gives room for that octagon to fit. So there and there, um, those cross references are showing up again. And if you remember the video where I sort of modified that symbol, I had no idea why they were actually showing up. They shouldn't, and I'm going to chase that off stream because I kind of hate it. Like the cross references are in the octagon. Why would I sort of care? And we got our cross references in. So the spacing I did, like I said, the spacing here gave us room to fit those octagons, and that's plenty. Can I just delete that? Nope, it deletes the whole symbol. Um, Attributes, file row. That's the stuff, the red and the blue inside. Properties. Oh no, I don't want. I I got to be honest. I don't even know what that meant. So I'm going to divert since we're doing this live. I do not. I mean, this is not a good look. It's just not because inside the octagon is our cross reference. So I'm going to check configurations and probably. Well, let's check cross references first. Okay, that's not. That's. I don't think that's right. Cross references. This location for cross references is what happens if we use a relay. So that is not normally yeah, that is not what I want to use. So we're in the wrong spot. And pardon me while I take a moment to try to figure out why those ugly cross references are still showing up. Let's check. There's only a couple. I mean, the odd part for me and why they're showing up is there's only a couple of places they could be defined, like here in the actual symbol. If I go to properties, like without cross reference means it shouldn't be there. But that's literally what without means. It should not show a cross reference. That's and this one is set the same way. I checked this on the older video. That's what bothers me. That's the part that really bothers me. And even if I open these up to like edit them, like there's no text here. This gray is just telling me that it goes to this circuit, right? If a cross reference was actually going to print out here, it should be black. It's not black. That bothers me. We don't need to save it. I didn't change anything. So I'm only going to a minute or two more because this is diverting from the real point. Let's check project and what about symbol? Nope. Nope. Attributes. Nope. This is where we can sort of define some cool stuff too. Origin destination. So that's setting origin destination. That's setting certain features there. But we got that. I mean, that's already, there's no, let's try this. Mark origin destination. Okay. Maybe a mark. So I'm going to edit the formula and just get rid of that. Can I do that empty? If you want an empty result, quotation marks. Let's try it. Apply. Okay. Hey, they went away. So it was marking them with that. Good to know. All right, that diversion aside. So we need, uh, I mean, whether it's actually listed in here or not, I believe it is. Main circuit breaker. So I'm going to check 1489 A3C3. I'm going to see if that's in my database of parts. Otherwise, I mean, it's quick enough to create manufacture a part. Not that I want to insert it first. Well, no, first I want to see if it's there. I was in the right spot. So let's check circuit breakers. And like I said, I downloaded a ton of Allen-Bradley stuff. 1489 A3. 1489 is going to be, if I can remember my, alphabetical order here. 1489 does not look like a thing that I've got. 1489. Maybe. Yep, there they are. For some reason, it's not completely alphabetical, and that was A3 C300. A3 C 300. Right there. Cool. So we've got it. Let's double check. Three circuit breakers, circuits. Cool. Now, I just wanted to make sure it was there. So schematic, we will insert a symbol. We need another symbol. It will be a circuit breaker. It will be a three pole, and a simple three pole. So this guy, not one with like the thermal or the magnetic trips or anything else. It's just a simple three pole circuit breaker. SolidWorks will automatically flip it. You can also use the space bar to sort of rotate it, or the icons over on the left. I like to sort of automatically rotate it because I'd rather have it facing this way than, let me go back to default. SolidWorks wants to flip it the other way. I prefer when you now, usually, let's be fair, usually default will throw them in there horizontal like this. On the three-phase run, the main usually goes vertical, and in the case that it goes vertical, I like it oriented like this. It's just personal preference. That's why, again, I mean, a lot of this is either personal preference or what your customer dictates. So a lot of it really goes down. So AC, I kind of hate that. I'm gonna not gonna lie. I'm gonna change that to just CB, just CB. Um, and do I want to change? I kind of do. I want to change my part mark. So this is entirely optional. I like. Let's go to configurations, and I believe that's under project. I think mark. So cable drawing components, location function component. So component root and order number, this is the function that it's going to use. So the root is the CB that I entered, and the order number you saw as a briefly a one is what it was going to put in there. I don't like that. I want, um, and actually, is this root component order number on three characters? That's not, doesn't have the way that I like it, does it? If letter, okay, we're going to combine two. So I want root plus order number, or not root. I want root column line, just like we number wires. And if you see me looking up here, I'm used to looking at this webcam, but because the streaming software is on my desktop and SolidWorks Electrical is on my laptop, I'm on my laptop with my desktop monitor plugged into my laptop. I need this camera, not that one. Um, so that's what happens if you see me, talking into the wrong camera. Anyway, what I want is I want something like CB page 1, row 4, which I think is where this is going to go. That is going to end up being something like this, but not quite. So it tells me here in the description, right? File order number plus row number plus root. The root is going to be the CB, and then plus a letter. So I'm going to combine a couple of things because I really want root, right? I don't want this file order number crap in front of it. I want root, and then I want row number, and then I want, or actually I want root, page number, row number, and then I want a letter. So I need to get in here, and I want to see this formula, and I want to copy all of this. This is the letter, and the letter is the hard part to remember, like how to write from scratch. These formulas aren't hard, especially since, like, I can edit this. I can go to variables, and it gives me all the variables I can grab automatically. So I'm going to grab the root, component root, plus row number, row order number, boom. And actually, I don't need to even put the plus sign in manually the way I did it. Except I forgot I also want the page number. So that is going to be file order number. And I just want that. Well, do I want it on two characters? I kind of do. So two characters. Yeah, let's do it. So it'll be 0, 1. No, not for components. I'm being picky, and it's up to you as the designer. Like, be consistent. is the big thing. Be consistent, follow again. Everything gets trumped by whatever your customer asks for. So if they have a standard, guess what? You're following their standard. But I want the row order number. So um, what I can do is I can again combine. So if we look at this string Z value folder order number 2 characters, I do want the row in 2 characters. So like row 01. So I can sort of copy that and instead of folder use the row, which is what I'm going to do. String Z um, val and row order number, close that parenthesis, comma 2 comma 0, and just copied that. That's all we did. And now I've still got that other thing pasted for the letter. So what this is telling me, component order number. So if it's the first one, don't put anything. It's that simple. Then character is going to pick from the ASCII table. That's a topic that I go over with students in an early PLC class, what ASCII tables look like. It's going to pick in the ASCII table character number 33 plus whatever the order number is. So 1, print nothing. So if it's 2, it's going to print ASCII character 65. ASCII character 65 happens to be the capital A. If it's 3, it'll be 66, which happens to be the capital B. So that's how we get the ABC thing. That's what I want. So I'm going to hit OK. That's what I want. Terminal strips are okay. While I'm in here, I'm just checking. Terminal strips are okay. I don't mind leaving those as just 1, 2, 3. Cables as well. The rest of that should be okay. Apply. Okay. Now let's drop our, finally, drop our circuit breaker in there. Drop it here. I want to leave enough room to sort of get a label up there on the wires. So Q, it's still used Q. I could change that. I'm not going to waste any more time right now anyway. If I find something else that's super annoying, I might change the route permanently, and you can do that again in project settings. Here, I'm just going to change it manually to CB. The current rating and stuff I don't need to do, but I need to find that part number again, and I forgot what it was already. 1489 A3C300. 1489. And again, in here, when looking, these filters can mess us up because some of the parts, especially, are Rockwell, some are Allen-Bradley, even though they're the same company. So you can clear these filters, modify, do what's necessary to find them. There it is, right there. Look right to it. Okay. So plus sign to add it. Once it's down here, we're all green. That means my symbol has the circuits required to fill that part. Now there's one other thing I'm going to add. I'm going to add a description, and that is going to be main circuit breaker. Again, whenever it lets me enter a description to make things simple, that's what I like to do. So manufacturer data, it kind of looks like Allen-Bradley didn't actually fill any of that stuff in because that should automatically populate. But we've got circuit breaker 404, which is what I wanted. That's how I wanted it numbered. It's telling me it's a Rockwell automation, which I don't actually think is correct. I think if you buy this, it's going to have Allen-Bradley's name on it, not Rockwell's. But I mean, we live with what we got, right? So, and then the part number, which is good. So if a maintenance guy, if this thing ever goes bad and a maintenance guy has your drawings, again, looking at the wrong camera. Hi. If the maintenance guy has your drawings and the circuit breaker goes bad, he knows exactly just with this schematic in his hand what part to replace it with. That's sort of the key that we are going with. Now, this is not explicitly called out that we need to include a motor, but it's a thing that we know exists, right? We're throwing somewhere, going to throw a motor starter in that we need a motor for. So I'm going to go to other symbols, and so I'm going to throw the motor in, even though it's not explicitly said it needs to be there. Like I know it needs to be there. So we got a 3-phase AC motor with 3 terminals. It's cool because AC is what I've got. And I'm going to throw it in. It's already oriented sort of sideways. Now, again, this is a IEC version of the symbol. Well, let's check and see if there's an ANSI version. They don't change much. They're both circles with leads. Is there one that's already sideways? Separated phase, that doesn't know. Well, yeah, we'll use this one. This is already sideways, so this is already ANSI. Set that back to default, and it's in the right sort of order. Bring it over here. M405 is fine. Description. Do we have a description of what that motor's doing? I mean, again, it wasn't explicitly called out that we needed the motor, but we sort of know we're controlling a motor. Therefore, it's probably a good idea to throw it in. It's a matter of, again, professionalism and completeness. So, what is it? Box eject conveyor. Okay. Box eject conveyor motor in the description. That's really all I wanted. Now, I don't know what I've got for motors in here. I just don't. So, motor three phase. Like, honestly, I have absolutely no idea what this motor is, but it's all green here. So I'm going to throw it in there just for the sake of having one. Again, just for the sake of completeness. That's literally the sole reason I just threw that in there. So again, I'm going to draw a single wire. I need to again select three phase. I'm going to draw it from here and just connect it. And SolidWorks is smart enough to connect the right colors sort of where they go. So they're connected, right? Now we know also that we have a uh, contactor coils in here. So insert other symbol, and it is under, I do believe, is it under relays? No, because there isn't a relay. Contactor relays and relays right there. So three poles, normally open power. Now, this can get tricky because sometimes, depending on the relay we grab, it's not a power contact. The manufacturer parts that we may have downloaded in the past might have screwed with us a little bit. So I'm going to drop it in here and give myself some room. Uh, Again, this is going to be, I don't, K is an ISO standard. I like CR, control relay. Even for a contactor, it's a contactor, but relays and contactors are the same things. They're just heavier duty, right? Eject conveyor contactor. Okay. And then somewhere in the BOM, it suggested a part number for said contactor. Let's see if we have it in our parts outputs. Overload relay thermal. I mean, we can also throw that in there, but 100C09 search. I don't know what I have, and especially since. All right, so there's a relay coil. This is good. This is actually good. So I don't have just. It doesn't look like anyway that I've got a plain C09, but I got a ton of contactors. I mean, let's be professional. I have no idea how big the motor is that I just grabbed. So let's check properties just to make sure the contactor I grab, since I don't have that one, power. That's going to be 30 horse. Um, Current draw is the thing I don't know. Does it tell me in the description? 50 hertz, 400 volts. That's probably not great to use anyway. 400 volts. Oops. We're going to use it and plus 50 hertz. So very European. Anyway, I'm going to go ahead and just grab that first contactor because I don't have installed a better option. Now, again, for a full design, like I would go through like, I need to know how much that motor draws, yada, yada. But again, I can, CR control relay, I should change that in my like base setup. And then that C09 contactor 9 amps. Now, I'm green. Let's add it. I'm green on three because they do match the symbol. That's why these are green. They're normally open power contacts. This is not green, not because I don't have it, but because this symbol doesn't have it. Again, wrong camera. I can grab um, in other drawings, and I will when I get to the PLC IO. I can grab a normally closed contact and tie it to this part, which I will. Also, on an output, I'm going to use this relay coil, and then at that time, those will turn green. So I'm going to select to lock that in, and we're good. Um, and we're good. So we've got a control relay 405, Allen-Bradley 100C09A01, 9 amps. I have no idea if that is a good relay for this motor because I just kind of randomly grabbed the motor and randomly grabbed the contactor. But it's in there. Move it over and, well, and reconnect since I screwed that up a little. Move it over because there's also a thermal overload, and I want to see if I even have that part number. There's also a thermal overload, 193A. I do not. I'm going to check my library. I do not know where that would actually be. Thermal strip. No, those are thermal magnetic relays. Well, 193s. That's a good start. EA 193. EA. EA. Bimetallic overload relay. I mean, that is, it says it's IEC. Well, here's more. EA. Don't particularly know what the difference between. Oh, I think because one's Allen-Bradley, and if I scroll up, oh, one's probably Rockwell. No, yes, yes. So it switches. Same part number, that just two different databases I downloaded. Awesome. That's gonna. So again, as a professional deliverable, that would bug me to no end. I would probably get rid of the duplicates or change manufacturing things match. Um, for now, I'm going to pick the one without the AB in front of it because it looks like they grabbed that because it is Allen Bradley, and a duplicate part number can't exist. EA though, 193 EA. There is no just blank EA. And again, I don't know. Let's check properties. Properties. Again, I don't know. And they didn't even set. They didn't like set any of the stuff. I don't know what this part number is capable of, but that's the one we're going to use. So let's do it. Let's not symbol manager. We want to insert a symbol, other, and then thermal magnetic relays. We need a 3-pole thermal relay here. And RT. I honestly don't know what the ANSI or what the ANSI or even US, even if they're not using ANSI, a lot of folks, even if they're not explicitly using ANSI, a lot of folks in the US use sort of ANSI standards without even knowing it. I have no idea what a thermal overload should be labeled, so I'm going to leave RT in there, even though I'm pretty sure RT um, is ISO naming convention. So EA is what I want. Does that one work? No, because everything here is blue. So that doesn't actually work. That doesn't work. None of that works. Oh, bimetallic overload. Okay, do any of these work? No. We'll see green here work. What are these circuits? Miscellaneous types. This also may be Allen Bradley just not using the right circuits, like miscellaneous. Uh, L2, T2. So that's only a 2-pole anyway, so that's not good for us. So we're good. I mean, this is a 3-pole with some extra contacts, but it's not thermal. Why would they not? I can change it. I can change it. I probably should change it. I'm going to change it. So I'm going to use this one just because it's a part number that's in here. Um, Overload relay reset, manual reset. What are these? None of these give me thermal, but they're in the thermal class. So I would not do this again professionally. I'm going to assume that since they're in the thermal class, they are all actual thermal relays, bimetallic, especially the bimetallic overload. And so which one is, well, I'm going to grab one with 3 poles at least. 193 DPC88. I have no idea what that relay is. I don't know the catalog number off the top of my head. I again would double check all of that, but I'm going to go in. I'm going to get out of this, edit that part number so that these are thermal magnetic protection relay to match these. So we get out of that. We go to library and manufacturer part, and we go down here to thermal magnetic relays and 193D, right? D something. D. Is it this guy? DPC88 circuits. It certainly was, and all I got to do is change these to thermal magnetic protection. thing to be very careful of when you're doing this is to make sure that like you don't have existing sheet sets using the other version, like the original downloaded version, because if you go to change those someday, that change is now permanent in my entire installation of SolidWorks. So if I go to change an existing drawing, um, if I go to change an existing drawing that used the original before I change that, and then I update it, it's going to change that drawing, and that's one of those changes, excuse me, that I may never see. So, so we throw the protection in there. Now this is a relay cross reference. That's what this symbol is. That's what this symbol is, and it can be difficult to fit that on here. And I'm actually going to make a command decision because this was so easy to do. I'm just going to delete this. The cross reference is 2, and I'm going to change this back to sort of the original title block that it had without the columns. So replace uh, ANSI B with rows, right? I need something. I need row numbers. I need row numbers to at least, label my thing. So this is still in row 4, or it should be. But now I got, the whole width. So that gives me room to sort of drag this over here, that cross reference over here. I can drag everybody else and give me some space, which is a good idea. Reconnect any wires that moved along the way. Let's space some things out. And this is, I mean, it's kind of normal. Like, oh crap, things I drew didn't fit. Oh well, I mean, we shuffle some things around. This is still the early stages of the drawing. So just reconnecting wires because I moved things and they disconnected. That's all. Just reconnecting. All right. So we got all that in there. I mean, again, might space that out so it looks a little more pretty, but this will be the cross reference for where the other or where the other contacts, I should say, for those relays land. So we're good there. Next, we've got protection on that bad boy, so we're covered. We're covered. Um, and actually, that should probably be OL for overload, but um, we're covered there. Next should be power supply? Question mark. We know we need to get 24-volt power out of this now. This sort of bill of materials, and again, admittedly, I use Gemini. I let students use Gemini. I don't hide the fact that I use Gemini. I do caution students that, I mean, and to students watching this now or live or in the future, remember that you're students and Gemini still has a tendency to hallucinate, make things up. And as students, this isn't trying to be insulting, but you may not know when it's making things up. So I don't actually recommend to students to use it with anything that has like a technical answer, like solve this problem for me, because you won't know, right? If it gives you a wrong answer, and then when you give it to me, I got to assume that's your answer, right? You put your name on it. I'm okay with you using it, but what I recommend, especially for students, is get the answer and then, hey Gemini, can you expand on this? Can you find the key summary here, something, but you give it the answer and you might have it massaged. That's my recommendation to students. With more experience and more, basically just that, more experience under your belt, when you have a better chance of catching its hallucinations, then you get a better, uh, you're better able to deal with them when they happen. So 24-volt DC power supply. Now, this one will work, but it requires a setup that I don't really like. This is a 24-volt AC power transformer, so it's going to take our three-phase in and spit 24 volts out, and then we can run that 24-volt. Well, we can't run that 24-volt AC, so this is a 120-volt DC, or 120-volt power supply. It needs 120 volts to run on. It's not three-phase. Now, there are three-phase power supplies. So I'm actually going to find one. I don't know if I've got one in the library. Let's check. But I'm gonna grab a three-phase power supply. Like I said, the bomb was there to give students a head start so they didn't have to spend like hours shopping. So actually, in my browser, did I leave? Nope. I thought I left Allen-Bradley's website open with their power supplies, but gotta be honest, I don't necessarily like Allen-Bradley's power supply, so I might see if one of these Weidmullers here is. Now they don't give me very good descriptions, right? 24-volt power supply, yay! What's it take coming in, right? So I might go to Weidmuller and see if one of those is online catalog. Is the best way to get there. I much prefer their power supplies. Now that said, I hate kind of in general what I am about to do, which is grab a three-phase 24-volt power supply. I got to remember which one of these do I actually want because there's like four ways to get there. I think it's the technical catalog. I do not want the PDF. I want the version that I can click through. Technical products. I don't want the PDF version. In BME CAD form. I don't know what that means. Products from Weidmuller. Which one? Which one? Maybe that one. Visit our online shop. Did they rename it? Kind of looks that way. They used to just call it. All right. So power supplies are going to fall under electronics, maybe relays, power supplies, and switch mode. Doesn't really matter. Switch mode, connect power pro. There's a whole bunch of different versions here that we can connect power three phase pro eco. Let's try that. Part numbers three. They're going to start with 3 0. Do I have any? I don't have any 3 zeros. Input voltage though. Oh, there's some that have me. Input voltage blank. I like it. They didn't actually tell me. Can I do a search? Yes, I can. Let's search for that part number. Easiest way to do that. All right, this is already, I can tell, going to be 120 volt because it's only got two contacts. What about this guy? Same. This guy? Same. Lame. Does nobody have a three-phase power supply? I guess we'll go back to Allen-Bradley's world. I mean, the 1478s are what? We're 1469. Let's search on that part number and see what it is. That's also a single phase power supply, but we can at least search on this part number, see if in that family, hopefully, I mean, maybe in that family. So 72 watt, soon be unavailable. Okay, 302 is taking over. That's fine. That's the thing that you can't always, deal with, but that is single phase. So Pro Eco is kind of looks like where we want to be. Pro Eco. Yeah, we were in three phase though, weren't we? Damn. Oh, I bet those are the new part numbers. I wonder if I go down into one of these guys. So first let's make sure it's 24 volts. And search on that guy. I bet they're all getting a part number refreshed. That would be my guess. Switch mode power supply. Are you single phase? You didn't actually say so. L1, L2, L3. 24 volt, 40 amp. Now, 40 amps. 40 amps is an absolute hoss. A 40 amp power supply, I mean, that's big. Like I default to 10. But we're gonna use that part number because I got it and it works. So we're gonna drop in the symbol first and then attach the part number to it. So we want a different symbol. We want to go to power supplies. Power supplies. I want a three-phase AC to DC. And what I had started to say, now this I'm going to draw vertical on purpose, in sort of not vertical necessarily, but the IEC. I'm not going to rotate it like that, right? I want it default. Um, I want it default, and there's a reason for that. First of all, this needs to be PS power supply, and this is going to be 24 VDC. There's a space power supply. Okay. And what I had started to say before is I'm not nuts about not nuts. The thing that I started to say that I'm going to do that I hate. I am not nuts at all about. I need 24. Which one was the 24 volt? That one. The power supply. Power supply. Why do I have extra? Why do I have extra? I'm sorry. Ew, because of how they drew their symbol. Is that right? Let's select it. We can always change it. Something's not right with how that's labeled. Yeah, notice. So plus here would be, it has to do with how they drew this, or with how this default symbol is and how the manufacturer part came in. And the only real way to show you sort of the difference is going to be, well, first I want to make sure I want to make sure that in the power supplies, I want to check one of the Allen-Bradley ones to see how they did it. So Weidmuller, what is wrong with what Weidmuller did when they created this? If I double click on this and show the circuits, there are only two power supply circuits, period. This one's got four contacts, three legs and a ground. This one's got two contacts, so this will be the output. When we look at the symbol, if I edit symbol open, there are five power supply contacts. They use a separate, or circuits. They use separate circuits for each connection point, and we can't do that. So I'm going to modify the symbol again. You need to be very, very careful doing this until you get a feel for like your workflow to make sure that you're not screwing up other drawings that might use this same symbol. I'm not. In fact, I said I was going to check. Anyway, connection point. I need two power supply circuits. Connection point, boink, there, and connection point. So three connection points to the same circuit. The second circuit gets two connection points. And this is all, I mean, this is all part, unfortunately, of SolidWorks Electrical. I'm not, necessarily nuts about it. Can I change orientation all the same? Yes, I can. I should be able to. There we go. Except you didn't. Why didn't you? Why didn't you change orientation? I'm sorry. Rotation 0. Thank you. Let's also center it because I like these to, well, can I? I can't. I can't. I was going to say I like them to be inside the symbol, but that DC label is going to get in the way, this DC symbol. So we'll just leave it this way. But I want 0 rotation. We're going to go bottom right and move it and make it all pretty. Again, this is just part of being complete and being professional, right? Making these symbols look good for our, importantly, for our use. But again, be incredibly careful that you're not affecting like other things that use this symbol. Like that's kind of crucial. Those should actually, now they overlap because they're variables, but those should actually be okay. I'm going to save that. Control S it. I'm going to right click on this now and update the symbol, and it should fix my labels. Except you didn't. That's a thing that I can also fix. So symbol properties, and you can manually reassign these circuits. And I'm literally going to just drag and flip them. Clicked one, I dragged it down, I flipped it. Okay, so they're relabeled. I am going to change this one more time. Symbol edit or open, because this one I'm going to move to the other side of the connection. Again, what I'm looking for when I give these sorts of assignments to students is I want to see it look professional, right? I don't want to even say good. Like, good is subjective, and I'm not all that great at getting things to look good. I mean, look at the thumbnails I do for my videos. But it's about being professional, being complete, being consistent. I mean, honestly, being consistent might even be more important than looking good. Consistency is kind of critical. All right, so we got that. The power supply's in there. We now have a part number associated to it. It's not displayed here. I don't know why that is. I want that on there, so I'm going to open it one more time. I don't know why. I mean, clearly none of that stuff showing up, so we can get rid of it. I mean, none of that stuff was there anyway. Insert the manufacturer. and part number. Drop these guys in here, change their orientation, come up with the tag. And I mean, me personally, I like to shrink them so that they're smaller than the tag, not by a ton, but like the tag is sort of the hero here. There, save that. Update one final time, I hope. Symbol update. So there, we got a power supply. I need to connect it. Oops, single wire, single wire. Thank you. And select the three phase again. All right. I probably want to start over here this time. So start over here. I should need to come that way. Nope. I came too far. So that's the tough part sometimes with three phase wiring is remembering where exactly it's going to want to bend. Um, so let's start up here somewhere. And we know now that we need to bend there. Okay, cool. It's connected. I mean, just that quick. One thing we need to do that I always do is we need to protect this. Always protect the incoming on the power supply. Now, again, I'm not nuts about a three-phase 24-volt power supply. I'm not about it because, in my experience, they fail frequently, they fail early, and they fail often. Um, Worse, when they fail, they tend to fail at a frequency that I can hear. Um, so, sort of clicking, and I hear it, and a lot of times electricians can't, and it's one of those things. So it bugs me. Usually, I would pull two legs off, kick it down, maybe a 240-volt to 24-volt power supply, something like that. In this case, though, I'm not going to get that complicated because this meets the criteria for this exact question. I am going to insert another circuit breaker. Again, I don't know, like we need a three-pole. This is probably, did it tell me? It's a UL 489, and we don't want a 489. 489 is expensive, and this is a branched circuit. Um, we can use 77, but it's the same symbol regardless of whether it's a 489 or a 1077. That's circuit breakers, not a relay. Regardless of 489 or 1077, it is the same exact symbol, just a different part number. So manufacturer parts, search. uh what was that part? Well, let's get out of here and get back. That original was a 1489 A3C300. So I'm going to start there and basically look for one with a description that says 1077. I'm hoping if they put it in current limiting J frame, thermal magnetic. Come on. A lot of part numbers when you download entire companies' databases, like I did on that other video. You get a lot of part numbers that you might never use. 1489. All right, so we definitely want a three pole, so we got to keep going. And it kind of looks like, well, we need a three. Let's get down to three pole, but it kind of looks like the 49s are called out, and I'm going to guess that R means it's a 1077. And the reason we want to do that, like we have to have. All right, and let's do this. I will do this one professionally. So what I would have done with the motor, what I should do, is look at their data and see what this thing actually draws. Right, we need a circuit breaker that can actually handle the draw. Input current 1.3 amps. So we're not going to find a 1.3 amp and a quarter if we can get it, um, which we can't. We got a choice: 1 amp, 1.5. So I'm going to go with 1.5. I'm going to go with this one. And before I add it, I'm actually going to Google that and see Allen-Bradley 1489 AC A3C015R. AC3015R. I just want to see if it's a 1077. Uh, Boy, that's a price, and that's why I also don't use Allen-Bradley. Oh, that's an Eaton. Eaton doesn't. Eaton is not what I'm looking at. Allen-Bradley AC AC3 C. I missed it. A3C. I missed that. 3C 015R. Let's try that. AC3005. I want the R on the end. I want to see the R. Obsolescence. Rockwell announced in October they're obsolete. Oh, awesome. Um, so the 15 is a 489. It says so in the description anyway. I have actually no idea what the R means then, and especially since they're obsolete. I'm going to operate under the assumption. It's a big assumption. I would not ever do this professionally, but for this case, again, it works. This isn't an exercise in getting the exact correct component. I can't stress that enough. I'm going to assume that the R on the end means that this is 1077, not 489, especially since the description changed. I am probably wrong. Oops. One thing I do want to do is I don't want that to be a Q. That's a thing I can change. I can just change it right here. Circuit breaker, CB, right? And this is going to be the 24 VDC. Um, no, we're going to call this the power supply breaker. And, and, okay. So we got a breaker feeding the power supply. That sort of protects it from, nasty things happening on the inlet side. Now on the output, we're going to draw a wire. I want to make sure I've got my DC wire, which was this one that I customized in a different video, I believe. Right? No, it was not pink. It was blue. I'm pretty sure it was blue. Cross single wire. Was it not blue? I could have swore it was blue. I'm going to make it blue. That's in project config, wire styles, and I want that 24-volt control. You are going to be blue. Okay, it didn't save this either, so I don't like this wiring number or this wiring method. In fact, I don't like any of those. I don't really like any of those. I want so what I like my wires to be numbered is I like, again, page. I do page in 2 digits, row in 2 digits, and then a letter in case we have to, you know, more than one wire on that row. So we're gonna sort of make up a formula that will do that recent. So this was it's that cool. Replace my recent formula. It saved it from a previous video. So that's exactly what I want. File order number, that's page. Row order number, that's row, and both are in 2 digits. So it'll be page 01, row 08. And then if it's the first wire on that row, nothing. And then anything else is going to add A, B, C. Um, that's how I want that. And it's not violet. Why would you say violet? That is weird. Blue. Okay. Okay. And then I'm going to change my, oh, it also deleted. It didn't. I'm going to go ahead and create a new wire. 24-volt. I'm going to leave it magenta. And we're going to change the name to. I've never actually done it this way. That's kind of cool. Uh, Actually, can it be a neutral wire? Can it be a neutral wire? Like, why can't it be? Description DC common. I've never done it as a subset of a wire like this. Um, so let's try it. I mean, we don't have anything to lose. I mean, it'll pop up that same way. Yeah, that's kind of cool. So control, right? 24-volt. It's blue now. I'm going to come down. I'm going to sort of splay it out this way, and I'm going to come out a fair distance. Why am I going to come out a fair distance? Because I also want protection here. I want a circuit breaker on that, and it's going to be a 24-volt circuit breaker. So, and that'll kill. So I can kill the power supply with this one. If you think about it like a switch, I can kill the power supply with this one. It also protects the power supply. I can also kill just the DC. Um, and then let's draw the other wire while I'm in here and get rid of that. Draw the other wire while I'm in here. That's kind of cool. I've never done it that way as a subset of another way. It's always been its own thing when I've done that. So we got main power, we got disconnect, we got motor protected, we got power supply and protected. We need a single pole circuit breaker right there. There's a symbol for it. Drop that guy in here. Again, CB. And this is going to be the 24-volt DC breaker. And we need a part number to match that. Circuit breaker's base. What is that power supply put out? Get rid of that tab. Maximum. Oh, that's right. It was ridiculous. Wasn't this the 40 amp? Yeah, 40 amp output. Current consumption related to input voltage. I just want to double check. Output 40 amps. Continuous output 48 amps. Oh, if it's cold. So we're gonna protect it. Now, NEC, I believe, has rules. I don't know them off the top of my head. That would be another thing that I would be double checking. But for now, circuit breaker, probably a C curve. C curve's kind of normal, and we need one that's 40 amps. So that guy, I mean, I don't see a reason why not to use that guy. I don't know what a 188 family is from Allen-Bradley, but we got kind of everything we need. All the information here, so that's good enough. Again, for this exercise as an exam, that is good enough. Now, this sort of three-phase power for now is kind of complete. So I'm going to hop over to control power. And I'm going to do the standard ladder setup here for control power. For now, now in a video, I did recommend doing this instead of in ladder, doing it with terminal strips, and I still recommend that. But again, that's not really the goal here. The goal is to get a complete set. That's what this exercise is. Just give me a complete drawing set that meets these criteria. So I'm going to forget the terminal strip idea for this particular project. But what I do need to do is I need to cross-reference and get the power from this page to the other page, and that's the origin destination thing. So single insert, start here, feed here. All right. And while I'm here, continue it over to this other rung. So go to the purple, or the common, feed there, here, and here. And when I close this, I now have cross references. So page 5, row 1, right? Page 4, row 11. So I've got all the cross references. They show up. 515 is where this picks up. Look, 515. So that's sort of done for this. Now what do I got? Let's see. And we may not. I may be incorrect if I look back at the description. What do we actually have? We may not have to have a separate power page like that because of how simple this system is. Man, that's a tough call. I'm going to leave it. Um, I am going to leave it there, but I don't think there actually needs to be anything on it except what we just did. It better be. You got a sheet, unless you're going to put like intentionally blank. There better be wires on it. Let's fair. Uh, but I don't think there needs to be any. I'm going to add a sheet though. New scheme. Schemes are wire schematics, right? Schemes. We're going to change properties. This is going to be our PLC main. Yeah, PLC. Let's just call it PLC 1. Let's just do it that way. I'm going to create a PLC in my project PLCs. I'm going to select the project so that I can add a PLC. Let's add a PLC. And I need that 5069. All right, let's go to all again. L306. Select. Okay, so I got L1 or N1. I don't like that. That N1, I'm going to change that to PLC. Hey, look at me. PLC. All right, and this is going to be the main. Again, everywhere I could put a description, I'm going to put a description. Okay. Okay, so we got our main PLC, right? I'm now going to add a module to that PLC. As a rule of thumb, I'll put the inputs first. So I'm going to add that an input module, right? And I'm going to change again the title. I don't like N, sort of the PLC default. I'm going to call it in. Fair, I think. Um, okay, and then I'm going to come back up. Make sure not this is selected that this is selected. I'm going to add another module. I'll do the 5069 thing, and I want the output all 5069. Oh, now do I have an OB8? Don't I didn't create it. I didn't create it. Can I get rid of this? Can I get out of that class? Let's go to any class. 5069, because the OB8 was specifically called out, right? Or the OB16. Yeah. I don't want like there's this output card, but that's relays. Um says normally open individually isolated relays because the relay module is going to require extra wires that I just plain don't want to draw. Right? Right? Is that a true statement? 5069 OW16. I'm going to check it. 5069 OW16. I'm going to check it. Um, relay output. Drawing is not really what I want. Documents. Technical data. That's going to be all of the 5069 cards, um, which is fine. You just scroll down until you find the one you've got. I want to see wiring. I want to see this schematic for the OW16. That's what I want. That's what I'm here for. Because if I can use it, I mean, I've already got it. That's fine. Relay versus digital in this case is not going to make a difference. OA16. That's AC out. OB8, OB16, OW4, OW16. I just, yeah. There's a lot of extra connections here. There's a common in the middle. Then that's really because you have to power the relays, right? You have to give the relay contact something. So what do we have? Do we have 16? So there are terminal numbers here. I'm gonna do it. I'm gonna do it. I'm just gonna use it because it already exists, and I'm gonna rename it. Give it a new mark. I like to call them out because it's an output. I mean, why not? Okay. So we got physical address. This is where it's going to be a problem because there are 18 terminals. There are only 15 here, and we don't have. That's all right. I'm not gonna do it. I'm gonna delete that. I'm going to take the time here live to create the part that I need. Manufacturer part. And I'm gonna go and I'm gonna find that part because I can use it as a base. I can use it as a base. I need the 5069 though, so I gotta search for it. Filters. 5069. OW16. And does it exist? No. I might as well create the OB16 while I'm, if I add one while having an existing part selected, it automatically populates everything from the old one. So I don't have to change absolutely everything. So OB16 module without interface digital outputs. Change the category. User I like module without. That's fine. That should be a sourcing output. How do I know that? Because I've used it for years. Honestly, that's how I know that. So, but if you double check, since I already have this open, hey, look, sourcing output. Um, 16-point input. We don't want to use that. We also don't want to use this. 2D footprint is actually fine because these modules all have the same size. So that's actually perfectly fine. I'm going to leave that alone. These though, all of these guys, we got to change to outputs. And we can do that in bulk, actually. If I select them all with a shift, change them, and they all change. But we also have to insert proper pins. Oh no, on this one we don't. We do need 2 pins though for LA, and that's going to be because we need to power that, right? Field side power. We have to power this module. Otherwise the outputs don't get any power. So we got to add, and in this case it's at the bottom, so I'm going to leave it at the bottom, and we're going to add a I'm going to just call it miscellaneous. 2 contacts on that. All of these, notice, only have 1 contact. I'm going to leave 1 miscellaneous circuit with what do they label it? LA plus, LA plus, LA minus. Okay. All right. Everything's fine. Okay. Now I have the OB16 in here. Close. I can go back into my PLC now. Project PLCs in the main PLC. Add a module and add that OB16, and I should be able to just do OB16 and get it. Oh, look, it had. Oh no, those are 1756. This guy. So we'll do that. Select. Okay. Oh, I forgot to change properties and the mark to out. Okay. Close. So now let's drop them in. So schematic, insert symbol, other symbol, PLCs. Boom. And I'm going to use now in another video when I demonstrated how to sort of do the PLC setup that I just did. Um, I said that I hate their sort of default PLC stuff. I changed my mind like sort of live in that video, and actually kind of like it now. So I'm not sure which one of these though that we use for the PLC itself. Like, uh, I don't actually know. It's not terminal information. It's not going to be outputs. What do we use? Common. No, that's only got 1 circuit. What do we use? What do we use? Did I create one for that? It doesn't look like it. I created this. Oh, let's try. Now again, I don't do this. Or I changed my live video, or my live video. We're gonna try the insert PLC, and maybe that'll. I want to select an existing. Yeah. Okay. Select. Okay. There's the. So it's not inserting a symbol. It's inserting a PLC. Duh. All right. Insert that guy. All right. Rockwell Automation, CompactLogix 5069L306. Boom. Okay. We're going to insert, not an insert, insert a PLC existing. I'm going to insert the module, the input module the same way. Now, can I flip? I really, so the one thing I kind of hate is I want it, channel direction, change direction. Haha. All right. On top of changing my opinion live in that video, I have officially that I know I can flip it the way I like. I like my inputs coming from the left. Now that I know that I can do that with 1 button, like I'm officially in love with this. Do that. I'm gonna split it. I don't like 12. I definitely don't like 20. What about 2 cards? Okay. Okay. I see what it's gonna do. I'm gonna get rid of that. Uh, I'm also gonna do this. We're gonna call this. I'm gonna rename this sheet. This is the plan. Properties. We're gonna rename this sheet to PLC inputs. And I'll do 2 cards on this sheet, just the way that description said. That means I'm going to Control X, cut that out, and drop this on my control power page. Boom, just like so. Okay. The inputs now, I'm going to insert a PLC and add that. Select existing, add that input card. Select. Now it. Didn't keep my orientation. So flip that. I like that. Didn't keep. I want 2 cards per page. I like that. Let's do it. We're going to do that. And again, I like my inputs to feed. Now, I also, so this card is huge. Can I shrink that? I'll worry about it later. I'll worry about it later. I like it narrower because I want to leave a gap between these hexagons and here because I like to put text to describe what that IO point does. So I leave a gap. And with as wide as this thing is, we don't have a lot of room for that gap. And oh crap! And I did the 12 channel thing, not the 2 card. Fine, insert PLC. We don't have a lot of room for that gap and the actual input devices. For this drawing, I'm going to let it go. Bear in mind though, that is a thing that I mean, in personal preference, I like to do. So 2 cards per page. That's how I want it. I want my gap. I'm going to try to get it all. 2 cards per page. Uh, Fine, whatever. I'm not nuts about how that landed. But so there we go. We got cross references telling us where it picked up. We got inputs, um, 0 through 15. Good. I'm going to add a new scheme like right now while we're here and get that output card in here. New scheme and properties, and where are we here? PLC outputs. Okay. All right. PLC outputs. It drops the name in here automatically. Like I said, as a student, it's going to drop my name on the drawing set, which is kind of nice. It's got it doesn't have the project in our title block, but the title block is, as long as it's sort of consistent and we have information on it. But we got inputs now. Do the same thing for outputs, I guess. Existing. Grab this out. Select 2 cards per page. I dig it. Um, Again, I want a gap and change that back to 2 cards per page. I want a gap. I am going to go back later and sort of see if I can't shrink this symbol. Like I don't know what that symbol is. Symbol does not exist. So can I mean, how do I change? Sorry, I'm live and this is bothering me. And this is the sort of thing like you need to come up with when doing, engineering period. You need to come up with things that look good to you, that look consistent to you. I know I need this thing thinner. Like there's no way I can do this the way that I want with words here, components over here, and have room. I need to make this thinner. I honestly have no idea where it lives because I've never used it before. So let's try this configuration PLC drawing. This is the one. It's bold, so that's the one it's using. So let's see size, module width. Um, So channel separator, let's check. I want to check distance between those. That actually looks good. I might actually cut it down 1. If I cut it down 1, is that going to line everybody up? So if that goes up 1, that one would go up 2. That would put them in the middle, right in the middle of my rows, which is nice. So, and these are the things like the cool part is you get one that works. You find a style you like. You never have to change it again because SolidWorks remembers it. Channel separator height, channel height. And they're labeled here with D, so separator height is fine. Channel height is D. Channel separator width. Okay, so that's the C. That's that. Combs. Module width. I want that way less. I'm guessing half. That's a guess. I'm guessing I want it half as wide as it is. Um, that's it again. A straight guess. As far as separator width, God, I don't. Let's apply changes first. Close. So I changed the width. Let's update the symbol. Will it let me? I don't know. Update. Redraw. There we go. Oh crap. Because I selected 2 cards. per page, except um, I changed the wrong like version here. 0.875, right? It was 175. Yes. Let's try it at half with 0.875. Apply that, close. Let's set this as default, which we can do. Set as default. We don't need to necessarily add it to the project, but setting it as default will help some of that. Update, redraw. There we go. As long as we're clear here, it looks like it. So that gives us lots more room. Update, update, redraw. All right, so that's good. I like that. Now the height thing we're going to deal with real quick. 1, 2, 3, 4, 5, 6 is point 0.3. This is the difference between like metric and imperial in SolidWorks Electrical. I don't. It's a. It's sometimes a bit of a guess as to what the units actually mean. I don't know if so. 6 dots is point 0.3. Oh no, 6 dots is 0.75. Quick math on a piece of paper. If we don't know the units, what we can do, grab a clean piece of paper because I can maybe hold it up to the camera so you can see. Unfortunately, I can't just draw on my screen. I don't have my tablet hooked up. If 6 dots on the page, and I'm just setting up a rate 0.75. I want them to be 5 dots apart. So you can literally, if you remember algebra, let's see. I'm looking at my stream. Hopefully we can see it's little, but hopefully you can kind of see. So 6/5 equals 0.75 over x, and then we just solve. So 6x equals 0.75. Now there might be a simpler way to do this. Somebody's probably watching this screaming at me, you idiot. But I mean, this is, I mean, at a very minimum, where did my calculator go? At a minimum, this is like a low horsepower, low brain power method of doing it. I don't need to put a lot of thought into it. 7.5 times 5 divided by 6. 625. I should have known that. Those are okay. Fine. Fine. Call it that. Apply. Close. Close. Now, if I update, hopefully everybody should line in the middle. Symbol. Update. Redraw. Middle of the row. Middle of the row. Not even close. Not even close. Well, I guess technically that's probably because you are. Oh, you're off center. They would be in the middle. They would be in the middle. Let's delete them. Let's drop them back in and see what happens. They would be in the middle, except for they were inserted then in a wrong place. So let's do this. This. It's already all right. 2 cards per page. Good orientation. It remains. So let's drop it in the middle now. Everybody's going to line up in the middle of a row, which is kind of awesome. I mean, that is so 2 cards per page. Cool. That is kind of awesome. I'm in love. I have officially changed like a decade's worth of software opinions on their automatic cards. I'm a fan. I don't have to create symbols for every card I use anymore. I'm a fan. So there's that. I'll go back in a minute and actually redraw. I mean, we've got to kind of do these. Delete, insert, not that, insert a PLC. Existing main inputs, select. Probably got to flip them. I do got to flip them, which is fine. We're at 2 cards per page, which is good. That's what I want. I can come up to the top. That's fine. Come up to the top. I want a gap because again, I put descriptions over there. That's why I needed them narrower in the first place. That one I can't put at the top, so let's not, and then put this over here. Except why are those labels so far off? Now that bothers me that those are way over here because it would have been inside. All right, I want to see what the settings are, so we're going to delete. Cool part is like I haven't done anything that's not automatic. Like I inserted this thing automatically, so who cares if I delete it because I can insert it again automatically. Macros, I don't know what so like. Oh, I can make that wider. I guess an intelligent designer here would make it wider. So what do we got? Associate IO, dissociate IO. Uh, that I don't know if I need to do yet. I want to go back into the project and the configs and the PLC drawing because I want to check and see like how those attributes are located. Um, there we go. That's why. So F, E is good. Like that one shows up okay. This distance when it's in this orientation, it's in this orientation that we're kind of screwed. We need C and F to be smaller. Smaller by how much? Like, I mean, I cut the card in half, so logically, my first bet would be to cut that in half. 1.35 divided by 2 is 675 again, 0.675. That didn't move it all the way in. Like, right? You can see it didn't move it all the way in. So 0.5 should be clear of everything there. This one is a way different. That one is what, C? So 0.75, cut it in half to start. That's actually, that one's okay. That's inside now. Everybody's inside. Everybody's happy. Apply, close, close. Let's now schematic and we are on inputs. So let's close other tabs so I don't forget where I'm at. Um, and sort of an unwritten goal or an unspoken goal so far was to see where I was sort of time wise. And I'm only about an hour and a half into this stream, which means I'm an hour and a half into the assignment, the midterm, which means, and I've done a lot of side stuff that doesn't actually have to happen, but that, I mean, it also means I'm almost done. All I got to do is get IO, right? Um, and I diverted because I'm being picky, and you should. Again, if it was professional work, we absolutely should be picky about it, right? We want it to look professional. So let's get this up in the middle where it belongs. Let's get this guy. It can't go in the middle because we don't have the height on that slope, but we're good. Everything's inside now. I'm happy. Everything's thinner. I'm happy. The control power. Let's redraw this just because it should get skinny or update. Redraw. Okay, we're good. Um, we're good there. Now, let's get some power to this bad boy. Pins on that PLC. Well, first, I remember, and again, this is sort of in terms of a complete bill of materials, this would be necessary. So I'm going to do it here in my project, in my PLCs. I need to add, um, I'm actually just going to open this properties and go to manufacturer part. And I need to add the terminals with this particular PLC, the 5069 family. Allen-Bradley does not include power terminals. Like you will order it and have nowhere to put wires. You need to separately order them. And they are, I believe you need both of the now. This is not the right, like, this goes with you need to order these with your IO. This is a 16 point or an 18 point pin. This is a 6 pin. There's also a 4 pin, and you need a 4 and 6 for the PLC, and I don't have a 4 in here. Remember that, though, if you are watching this stream and looking for pearls of wisdom, God help you for pearls of wisdom, but you need an RTB4 and a 6 for the PLC itself. They actually sell them as a combo as an RTB 64. But you need both. I don't have both, but for now, just for the sake of completeness, I'm going to add it in there because I know it's necessary. I'm also going to do the same thing with the 18 pins for each card, properties that way um, associated with this IO card, with the other IO card. And again, I've got to change my filters. Any class. Um, 5069, and let's get rid of Allen-Bradley. That's just to goes to show you. So I'm going to add one of those. Oh, okay. Whew. I get a little nervous when it thinks like that and sort of erases my existing part number. So we're gonna go all class. I don't even care. I'm gonna open up my filters wide open and just search on reference. Where's reference? Right there. 5069. Just search on that and grab the other RTV 18. So again, and the cool part is, so I don't like the RTB 18 screw. I don't like it. They also have an RTB 18 spring. That spring clamps. I prefer that, but I don't have it. I'm not going to waste any more time creating more parts just for the sake of being a nerd. What I do need though is I need to remember what pin is what on this. This is the power connector for the PLC. So I need to remember what pin is what, and I don't off the top of my head. Um, I don't off the top of my head. Now I want this open, and I want the 5069 dash L306 ER manual. And they should, again, all be the same. I mean, there's not, the wiring is the same regardless of what size. The L306, 310, 320, that's basically the size of the memory. Uh, but we need this mod power. Yes. So this is what I'm talking. So you can see right here, 6 terminals, 4. You need to order both a 6 and a 4 for every PLC. But I want the wiring diagram. I want to see which is which because I don't remember off the top of my head where all the power goes. Um, I just plain don't. So let's check the contents again. Let's just connect the controller connection methods to set IP. That's all programming. Do we not have wiring? Memory cards, Ethernet IP, comms, IO, tasks. Yeah, yeah, yeah. Controller time. That's all Logix stuff. Studio 5000 stuff. Where's the wiring? Where's the wiring, Allen-Bradley? I guess if I zoom in right there is good enough. So we really only need to connect basically one skip 3. So plus minus. So let's draw it in before I forget. Draw a single wire. A 24-volt is going on 1. So I'm just going to wrap it around and connect it. Okay. And then on, so we got what? 8 terminals. That's not right. We should have had more than that. How did I set that up? Let's check. Properties. What do I got for circuits? Miscellaneous PLC. Okay, I see what I did. I see what I did. I set this up as, so the 8 wires were intended to be the Ethernet port. I remember now. The actual plus minus stuff is are in the terminals, the RTB screw terminal. I didn't create that, but that's not that's not correct. I'm gonna wire it knowing it's not correct, because 1 and 3 is pretty clear in the, mm, this would be pin 4 on the 4 pin, and then it's 1 and 3 and on the other connector, which, I mean, I don't like this, what I am doing at this moment. I feel a little dirty doing it, but it's getting done, and at the end of the day, like I said, for this exercise, that's primarily, realistically, what this exercise was about, is getting it. I want a complete sheet set. So, now I would protect those. So I am going to drop in a circuit breaker on both. I would protect those. And this is a thing, again, it's not in the bill of materials, it's not in the assignment description, but you cannot overprotect these devices. I don't remember what they draw. Um, Honestly, not a ton. There's not a ton of draw on the individual, but I am going to protect them. I'm going to probably throw like a 1 amp in there. It's more than that, I think. I don't remember off the top of my head, and it depends on how much IO you have plugged in and what it actually costs. But I'm going to grab a C curve, one pole. I mean, let's just do a 4 amp just for instance. Let's just do it. That's fine. Um, this is sort of the problem. This is why I modify a ton of my symbols, um, because they overlap lines. Like these lines are not close together, and realistically, we can't afford to have that much text just hanging down. So I modify a lot of the inbuilt symbols, like circuit breakers, for that reason. Oops, I got a little. Why are you way over there? Thank you. So for this reason, so the text isn't all over the place. And actually, I need to move it this way because I'm going to run into trouble adding one here. I want to protect both. Um, I want to protect both of those power supplies. Like I've got a positive wire going to two different places. I'm going to protect them both. And I would look in that manual, probably not that manual. Oops. Probably not that manual because that manual didn't have a whole lot of like technical data. It was all about programming, and we were on the 188. But I would find the manual, figure out what the max draw on each of those is, the module and the SA power, and protect accordingly. But again, for this, what I'm doing here is fine. I would accept this from students for this assignment. Um, get rid of that little wispy of a wire since I moved it. All right, so the PLC's got power. Yeah, PLC's finally got power, right? Let's give our inputs power. We're on inputs. Um, what do we have here? That card, that card, I don't believe, and I don't. Let's see. Can I modify the manufacturer from here? Properties. I think I can modify it in this instance. Let's add, and I did a miscellaneous, and I want that. So the IW, or I want the IB 16, just to see. Okay, they're not actually used. Okay, so I don't need that. Never mind. Never mind. Did it actually add that? I hope it didn't. 'Cause I didn't accept it. Okay. So yeah, we're not using those last two terminals. So the inputs are correct. The outputs has to have a power supply. So you need power the outputs. So bear that in mind. So inputs. I am going to slide you over a little more because I forgot about DC wires. Like we need DC positive over here. Again, I like to use the cursor space, and of course, cursor space changes depending on what your zoom is. But I like to use the cursor to kind of keep spacing reasonable and line it up again with the top and bottom hexes. And we'll do the same over here. And I'm also going to draw common on the other side of the IO card. So the common, I'm going to kind of hug the card a little more than I would because I still want to get text over here to describe the IO. But I'm still going to use my cursor. I use my cursor to kind of space it off the card. Same thing here. Sort of hug the card so I got a little room for text. I can sort I'll sort of demonstrate that, like, right now. I mean, why not? If we go back to the description here, uh, and we go to the IO map. So input 1, product count sensor. I would on here under draw, I can just add text without anything else associated. I would put it was called what? I forgot that fast. Product count. Okay. It doesn't have to say sensor, doesn't have to say anything else. Product count. I am going to shrink it. I'm also going to change it to left middle so that it's centered on that row. I'm going to shrink it. Text height. Try it in half. That's fine. If we look at it compared to all the rest of the text, and actually, I want it. I'm sorry, right middle, middle right. That way, I can line in all of them up over here, and they'll, if they get longer, they'll go this way. Um, but that's basically that. And I could go even probably even smaller with that text. But I'm just going to drop these in. How many inputs did we have? One, two, three, four, five, two, three, four. And I'm just going to go down the row and change these. And this is just, again, in the sake of completeness, this is just describing on the drawing what these do. So here, box present, cycle start, cycle stop, and reset. I would just call it reset. Oops. Nah, actually, yes, I do typically do these in all caps. That's just an old CAD standard, and I didn't do it when I first typed them in. So now I'm going to be a good example and go back and make them all right. So it's again, an old CAD standard that, text on the drawing should be caps. Not an absolute necessity by any stretch, and actually I am going to shrink it more. Height, let's not go half of that, but let's go 0.75, just a little less. uh get closer to like this text height here that's in there, and that way we have room for more words if we need it. Okay, so we're good there. uh and actually I want to drop this down if I can. And there's a reason, because starting up way high like I did, remember the cross reference is going to be here. That's not going to give me room for the wire, so I really need the first wire to be, which means all of these have to move down, like that. All of those have to move down like that. We're good. That one will be good. That one will be good because it's already on the second row. So what's first? An inductive prox. Schematic. Insert other symbol. Proximity sensor. That would be under detectors sensors. And again, I mean, you can sort of pick what you want. I've even used this symbol for a prox in the past. It sort of depends. Technically, something like this um, is a prox, or something like this. Normally, you open uh, three wires. If this is a three-wire prox, what part number did I recommend here? Again, the recommendation, literally just that we don't have to spend a ton of time shopping. So it is a three-wire 871C. Let's check and see if it exists. Manufacturer part management. So again, I'm not even 2 hours into this thing yet, and literally all I have to do is get these damn IO elements in now, and we're done. It's a quick one button to generate a bill of material, and we're done. Uh, so sensor and what was the part number? 871C. And actually, I can do a filter, and let's do any class. Why not? Just search it all. Just give me every part you got. 871C. Okay, I don't have it. I don't have it. I wanted it. I didn't have it. So we're gonna go in the same class. I'm just gonna see what I've got. I'm gonna use what I got. I'm gonna break the bomb. Inductive, 4 poles. That's fine. 4 poles, bailiff. I mean, M12, four. That's fine. It's a 4 pole connector. What do I got for circuits though? Sensors, detectors, 341. It all depends on how I did that symbol, on whether that's actually going to work or not, but we'll find out in a minute. Schematic insert symbol. Let's grab that 3-wire detector sensor. 3-wire prox. Where are you? Where's the one I drew vertically? Where are you? Right there. Normally open 3-wire. Um, drop you in here. And you are. I usually use PRX or prox. Again, I don't know what proper is. That's just habit. That's what I do. Detector sensors base. Let's grab that bailiff because it was an inductive sensor. It likes it. It's green. That means I got a place to connect everybody. 1, 3, and 4. One is common. Yes. Got to remember these are always going to be IEC standards. So one should. I'm working strictly from memory. Do not trust that statement from me that one is the common. It might be backwards. Three might be the common, but I think it goes this way. Three is our power. Um, and then 4 is definitely the IO. Okay. 4 is definitely the IO. That much I know. 2 actually 2 and 4. Some proxies use 2. Some I should say some M12 devices use 2. Some use 4. Some use both. Some have 2 inputs. One thing we need to do before I forget, from our control power, I got to get the 24-volt onto this page, so I need to do more origin destinations, and it's going to origin. Oh, not symbols. Just insert. Where are you? Single insert from here to here, from here to here, and then on that page continue, on that page continue. And while I'm here, I can also hit next drawings. And oh no, I didn't draw the wires on the output drawing yet. Um, but I could have continued that. So let's get rid of control power, PLC outputs. Let's get rid of the outputs for now. All right. So I got a prox. What was output one? Photo eye. Um, Other symbols. Uh, Detector sensors. Is there? I think there's is there an optical category? There was something. Measuring devices, transformers, data switches. I had an optical switch in here. Level, pressure, voltage, frequency. I had an optical switch in here because I brought in a banner part. Where did that end up? Let's check the manufacturer. Library. Now, it would admittedly, I'm wasting a lot of time if time is a concern. Again, a midterm exam, I mean, it should take a minute. Should. Let's be fair. But again, I'm not like it didn't take me days. And I'm wasting a lot of time because I'm trying to use the parts I have. It would actually probably be faster just to make the damn thing. But I want to check filter. And I know for a fact I made a banner. So I'm going to search any class, and it's going to take a minute because it's going to show me every part it's got, and I'm going to go down to banner. And somewhere. Oh, that's awesome that that came in. This is like the world's best safety relay. I love it. Sorry. Touch button, photoelectric emitter, photoelectric receptor, touch button, touch button, touch button, ultrasonic sensor. What does this have for circuits? Because I'll use it. I mean, I'll use it in a heartbeat. And what category was it in? Detector, sensors, proximity. Okay, so we're gonna do that. Schematic insert symbol. It's not going to be one of those. It is going to be. Yeah, I guess. I mean, that works. I think. Um, Actually, it's only got two, right? It had two. Wait a minute. There was a banner symbol in there. Was there not? Other? What is this? OTB is an opto push button, and that's a. I can tell by the way it's outlined that that is a QS. Now that is properties. It doesn't have their logo in it, so it's going to make my schematic kind of ugly. Holy crap, that's wait, I'm not throwing that massive symbol in here. Insert symbol, other symbols. Um, Other symbols. And I guess to try it. Let's try it with a normally open proximity. I do want to rotate you. You are going to land in here somewhere lined up. Yeah, see, this is so I would be drawing my own symbols and sort of resizing them photo eye. So I mean, opto, I guess, sensors, detectors. I want to go any class again, and I want to go with banner, and we want the emitter. Oh, it's a miscellaneous. See, damn it, that grr. Um, and I don't think I can drag because they don't match, so that sucks. So either way, I think, I hope, and I'm I mean, if you see a little squirming, that's suddenly I have to really use the restroom, and I don't actually have, since I'm on such a sort of cobbled together streaming setup, I don't really have the ability to just put up a, I'll be right back page, and I don't want to like leave you staring here with like no elevator music and none of that good stuff. But I think I'm actually in a spot where hopefully, see, anyone watching this, students that were looking for more input on what a sheet set should look like, this thing is complete except for actually throwing those input devices, and I can even throw an output on here. Do that while I don't want to waste time looking for the exact perfect out, er, devices. And um, but if I do this, I do need to get the DC power wires on this sheet. Okay, so we're there. And actually, I need to hug the IO more because I want text descriptions. I could also put the text descriptions over here. In fact, that might be better. Um, hard to tell. I'll plan it that way. So I'll scooch the card over instead and use the right side for the descriptions. Um, hard to tell which way is better. Normally, I would put the text over here. It's 50-50 proposition. But let's go here, draw our common, get that in there, and then I'll do the quick cross reference to get it connected. To get it connected. One thing I would do here, we got power here. I am gonna want to protect that. So let's connect the negative. We always put the breaker on the we always put the breaker on the positive side when we're dealing with DC. Just like in AC, you would put it on the hot side. Um, we use the power side. So here, 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 and I'll drop a breaker right here on this line. And this should be, if memory serves, no more than 2 amps, if I remember correctly. Again, don't quote me on that. It's been a minute. Like I've been a teacher for a minute and not a minute. I used to have random facts like that memorized because Allen-Bradley likes to stick with the same overall output for their cards, the same sort of capacity. Off the top of my head, I just kind of forget what that is, but they tend to be the same. So this is, um, let's see, output LA breaker. We'll call it that. Add to manufacturer parts search again, the 188 something. And then, like I said, I think 2 amps per card is what they normally do. Can't get down that low. Oh, I'm not in C yet. 2 amps, one pole, 2 amps. Select. Okay, good enough. I mean, for what we're doing, good enough. It's protected. That's key. Now, normally, also, I would protect each individual. How- where did I? Because I made that card too fast. I didn't rename them. Damn. Well, I didn't I should change the manufacturer part. Oops. Origin destination. I need to connect those wires to single insertion. Connect, 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 connect. They're connected. Close. Okay, we're connected. So the card's powered. Uh, the card is powered. So let's see. Oh, solenoid valve. Yeah, I'll do that. And then, well, no, I want to do both. I'll do these first three, and then hopefully by that point, that is, we can sort of call it a stream. So coming out of it'll be 24 volts since this is sourcing outputs. It'll be 24 volts. So these are blue wires. Don't forget that blue wires. So like sort of kaboom, right? These first two are insert other symbols, and we should have a symbol for a solenoid. I just have to find it. Like it's because there is no solenoid, I don't think, and it's not under pneumatic. Do we? Ooh, was that a true statement? I may have on my older installs of SolidWorks Electrical had to make a solenoid. Ooh. I don't remember. I might have had to make, but the cool part is, like, now that I'm in this category, this software is also actually capable of pneumatic and hydraulic diagrams. You just have to think in terms of wires, like it's going to use a wire instead of a hose. But like, look, it's got valves, it's got, regulators, the whole works, check valves, everything. So you can do uh, pneumatic and hydraulic schematics in here too, which is very useful. And I do that. Like, if this was a complete machine, I would do the air system on here too, because it's a complete design, right? I'm the designer. So anyway, I don't see this going. I think I had to create it. I frankly, I'm not sure I want to do that. I'm not sure I want to do that on this stream and just sort of nerd out and waste more time. Let's try. So yeah, there's no solenoid valve. No. Why couldn't I be that lucky? Let's go back to classification. Um, God, I was hoping that there would be one in here, but now that I think about it, I think I created it so that I had a solenoid. All right, I am going to create it because that is the right thing to do. Symbol manager. I am going to put it in pneumatic and hydraulic because that's like the first place I'm going to look for it. I'm going to create a new one. I'm going to call it solenoid. Doesn't need to be anything more than that. In fact, I don't even need a description because solenoid, with no description, it'll default to showing that name. No manufacturer, whatever, because it's a generic. Now, I do throw everything I create in user. It's just a habit. You don't have to. It is a multi-wire. That's fine. Display connection points. Keep attribute orientation. Probably. No cross reference. That's fine. Okay. And then we draw. And then we draw. Um, So a new circuit. I'm going to start with the circuit. It needs one circuit, more types. What do we got? Um, can it be hydraulic pneumatic? I'm not sure I want it to be hydraulic pneumatic. I'm going to call it a relay coil. And I'm going to do that because effectively that's what a solenoid is. It's a relay coil. But then I need to actually draw the symbol. So again, if you've watched the older video where I actually did this, multiples of 2.5. So I'm going to start at 0. I clicked to get the line sort of at 0. I'm going to go at. At means relative. I'm going to go 2.5 comma 0. So 2.5 in the x. Okay. If I zoom in, right, that's 2.5 units in the x. I'm going to draw a circle. Uh, and actually, that's fine. Ooh, yeah, ick. Um, Radius 0.5. No, because that won't give me. Yeah, I guess it will. I am going to draw another line here, though. Uh, so I'm thinking. So I want to be 2.5 with the circle, another 2.5. So I want to be like a total of 10 long. So I'm going to draw a construction line for now. You can't really construction line. It's just a line. I think I think to be 10 long. That's 10 0. So that'll be the whole length of our symbol. Let's do a circle. Instead of clicking now, I'm going to drop it at 1, 1 comma 0. The radius is going to be 1. Why didn't it take my radius? Sorry. Why didn't you take my radius? Like, why? 0, 0. First start. Oh, not 0, 0. I wanted 1, 0. Come on, pay attention. It's getting late. 1, 0 to start. Okay. It accepted 1, 0. Radius now 1. Because I'm an idiot and geometrically it would go back to 0. Okay. 1, 0. Start at 1. Start at 1, 0. Radius 0.5. Better. Better. like just plain better. Um, and then another circle. So if that was at 1, 0, this one is going to be at 9, 0. It'd be one from the other end, radius of 0.5. Okay. Um, and I can actually delete that. Draw a line now. Oops. I don't know, that escaped. Shh, turn my snap off. Oh, that was object snap. I want object snap on. I want the grid snap off. Uh, why didn't you turn off? There you go. So object snap is on, but why aren't you snapping to the object? Here we go. Can I not snap there? I guess not. I'm going to go here. I'm going to go over at 2.5, 0. The same thing the other direction. And we're just kind of, I mean, we're literally just, it needs to be an at negative 2.5, 0. We're literally just drawing a solenoid, and those are too long. I can tell right now. We're drawing the symbol for a solenoid. I'm going to go 1 unit at 1, 0. Um, at 1, 0. Ah, it need to be negative. Pay attention. Line at -1, 0. Okay. And now I should be able to trim. I should be able to trim, right? Modify trim, trim, trim. Select entity used for cutting. Circle. Okay. Enter. Select segment to remove. U. Enter. Now I lost that line. I'll do the same thing over here in a minute. The actual. So this was 10 long, the whole thing. So we're gonna do where I'm gonna try to do this with one line. Draw line from there. A solenoid goes basically up here, almost straight down, and then back up to this. So I'm gonna try to guess, and I'm gonna go straight. Well, no, I'm not gonna go straight down. So we're gonna go 5 would be the middle. We're gonna go to 4.5 absolute, not relative. I want absolute. 4.5, comma, let's make it 5, Paul, so 2.5. Okay. And we went 4.5, so we need to go 5.5 to get to the other side of the halfway mark, negative 2.5. Again, absolute. And then, like, I don't have to worry about that one. I can just connect it. That's not quite like spiky enough for a standard solenoid schematic, but it'll work for what we're doing here. So modify trim, boom, circle is the cutting item, trim that. And then I need to get those lines that I deleted back in here. Draw a line from here to 0, 0, and then draw a line from here, and I'll retrim to 10, 0, and then trim both of those. Modify trim. Circle is the cutting items. Trim the middle. Okay, and then I got to get out and do it again. Circle is the cutting item. Trim the middle. Okay, good. And we'll insert here. We're good. We need circuits. We need connections. Where are you? Symbol. There we go. Connect. Been a long night so far. There. Connect one end. Connection point. Connect the other end. We're going to zoom out. Those do not need to be that big. In fact, I'm not going to leave them that big. They are going to be half of that, 0.75 for both. Um, okay, we need to add attributes. We need insert attribute. We need a tag, of course. And that's going to go here. Make sure it's aligned center because that's the way I like it. And since I'm drawing this from scratch, I'm going to do it right the first time. That's somewhere in the middle. Now, a standard solenoid symbol would be just a little more spiky, like a little more intense angle, but that's fine. More attributes, just manufacturer and part number, really. Man reference. Good. Boom. I'm going to shrink them both and center them. So shrink them both and center them. And then this guy slides like straight up and save it and call it done. So that I can finally drop them in my schematic. Schematic insert symbol other. I'm gonna look. Oh, coil. I could have put it in coil. In fact, I didn't look. There's a solenoid right there. They just call it a coil. Let's use the one they created. I just wasted 20 minutes of your time. I apologize. That is how it goes sometimes. Solenoid. Uh, I don't actually know. Like, I don't know if there are valves like in here. So, I mean, for now, I'm just going to leave that with no part number. Oops. I do want the symbol in there. And in fact, I'll do both. I'll insert this symbol and then let's call it solenoid. I'll show you how. I mean, the created one sort of pops in there because it's. I mean, I created it, right? It's worthy of being included, and I put that under what pneumatics and hydraulics, and I just call it solenoid. And so there, right? Again, I should have renamed it Soul, but you sort of see the difference. And this is closer to the symbol I would normally use as opposed to this guy. A little more clear that it is a solenoid. But for now, I'm not going to bother giving those part numbers and creating manufacturer parts for those. There's a video on this channel how to do that, how to create manufacturer parts or even import them. I'm not going to go through that right now. But what I am going to do is I wanted to get those in so I don't have to do things in order, but I wanted to get the motor contactor coil in there. That's really why I just went through all that. I wanted to get those in there populated. I could have just jumped right to this one, but in the interest of decided I wanted to also get the relay in. Relays. I'm going to switch to contactor relays, and in here somewhere is going to be a relay coil. Um, well, coil, coil, relay coil. It's just a circle. Now, the relay coil is one of those symbols that I end up almost always modifying and changing where labels and things are. Now, we do have this is why descriptions are so important when you're trying to pick things out of this list. I need to associate it with the existing relay, which I think is this one. Nope. Nope. That's the motor contactor. Um, RT. Where is that relay? Like, ooh. Well, I mean, I don't see it in the list. Let's double check. It was on. That was the motor contactor. That was the motor contactor. I need to be smarter about my memory. That was the motor contactor. So that is CR05, 405 rather. So I just selected it from the list, and when I select it, like the only thing open is A1 and A2, which should be the relay coil. I hit OK. Like boom. We also get the cross reference here. It's telling me that on page 4, line 4, I will find these contacts. And if I go back to page 4 and go to line 4, right there they are. Also, this one should have updated. Oh no, because that's the cross reference for this overload, which we can also throw in on an output. In fact, we probably should. I'm not going to because again, this is now 2 hours long. But again, or just over 2 hours. So just over 2 hours. This sheet set is like 90% right. I can get another 5% in a couple of clicks, and I'm going to do that right now. So part of the process, so on the process tab, is to number new wires. They're all new because wire numbers don't exist anywhere yet. So I'm going to have it number all the new wires, which is basically all the wires, right? So 720. I'm not. Oh, 720 because it's on the other side of a breaker. But if I show this label, and this is part of completeness as well, I want to see um, like coming into this should be labeled, even though it's labeled here. Coming into this should be labeled for clarity, and going out of it on both sides show hide wire marks. And it froze. Question mark. Why did it? There we go. I don't know why it thought so hard. I don't know why it thought so hard, but and we've got numbers here. 411, 411, because all the way back to our control power drawing, all the way back to our control power drawing, like coming out of, or even further, main power, right where our power supply was. 410 out of the power supply, circuit breaker changes the wire number to 411, and then basically 411 is our DC power distribution all the way through. So that's numbering the wires. And you can see the three phase got labeled. Now, again, all of these should show their labels. Show hide. I want to see them all. And for the sake of completeness, these from an aesthetic. So SolidWorks Electrical automatically centers them in the wire. And the red one is longer than this one, which is longer than this one, which means these are all off center. Sort of the last step is to align them. And we just select them all, right click, align text. And you can pick any you want, but you'll see a green, like that guy sort of pop up, and that's the center. You can pick the center of any of them, or any point really. But I can just grab the center of one and just draw, and it'll line them all up to the line you just drew. That should be sort of the last step to make things kind of pretty. And you can move them closer, like if you wanted to show them right over here, so that it was very very clear to a technician. You could do that. That's fine. So we just took it from like 90% to 95% because our wires are marked. So like literally all that is left electrically is to get more IO in there, right? To get the actual IO points. I'm gonna go ahead and I'm gonna delete that line diagram now because I'm not gonna use it. I'm not gonna use it. But now I go from sheet two to sheet four. That's a problem. That I can do in my process again. Is it process? It might be project. Project process. There. Oh, yes, it was process. Renumber documents. So whole project recalculate order numbers. It's going to recalculate literally everything. And this is like literally. So you better make damn sure you don't ever do that when you have an actual like physical control cabinet sitting on the floor wired, because they literally will have gone through and changed rewired number as well. Well, not yet, because I didn't renumber the wires, but it will have changed part numbers and things, which I will do right now. I want everything to match. So this is a thing, like you can do it as many times as you want before you have something physical. But like for instance, I just changed the sheet numbers. I want to renumber my marks, right? Because power supply 408. This is now sheet three, right? I'm going to renumber my marks. Okay. Yes, and it warns you. So now it's 308, which is correct. Now I'm at 311, which is correct. I need to do the same thing with wires. I'm going to renumber, number new wires and recalculate all the way through. Again, perfectly fine at this phase. If you have built something to these drawings, do not do that. That is very bad. You can go ahead and number new things, but if you go blanket updating everything from before, you just wiped out everything that you built that cabinet to. No bueno. So So we're at like 95% now complete. I mean, we can get to like 97%. We need a bill of materials. So that's under project reports and literally drawings. Drawing list is going to be checked because it's already there. It's already sheet number two. Bill of materials. I'm just going to check it, hit OK, close, close. It added two sheets because the bill of materials is that long. Now we have an issue because the bill of materials drawings has that. And let's check the drawing list. Okay. So our template for drawing list and bill of materials has the wrong block. And let's check our main power. Is that one also okay? That one's okay because we changed it. Somewhere like 2 hours, 20 minutes ago, when this stream started, when I was messing with title to change the default for those reports, I need to change it back. So I'm going to open the reports. I'm going to go to my properties for the bill of materials. Right, I'm on that configuration. And we need layout, maybe. Default title block. No title block selected. Select a new title block. We're going to use B. Actually, just B without column because this doesn't need row numbers. Close. So now that's default. Same thing. Drawing list because that one also has the wrong title block as of right now. No title. Default title block. Going to be B without column. Apply. Close. And then generate drawings. And it will automatically overwrite what we have. It won't be new bill of material drawings. It's just going to update. It's just going to update. So, and notice now title block's okay. Right? Title block's okay. I'll double check the power drawings and stuff. These should still have the two columns that they do. Like the cover page we didn't touch. So we're like 97% complete. All at this point, if you've been following along and trying to complete that sort of midterm assignment. Um, at this point, all that's left is to get the rest of those IO devices in. That is literally all that's left. And at that point, I would do one more bomb update, and that's basic. So, hopefully, this was helpful. Hopefully, this helped out the students that were questioning and students in the future even that are questioning because this video is going to be on the channel. This stream, it'll stay there as a public video. I might hide it maybe so that I can sort of be cheeky and reveal it later on when the future questions inevitably come in. But either way, hopefully it was helpful. Hopefully it walked you through, and this is a view of what a complete sheet set would look like. As far as the one line diagram goes, honestly, anymore, I really only ever use that for Ethernet. And in this case, we didn't bother with an Ethernet drawing. Like modern PLCs, HMIs, and stuff. Any modern machine, realistically, like in the back of our heads, we know we're probably going to have Ethernet. But for this task, we didn't bother. So again, hopefully that was helpful. I want to thank you for watching. Have a great night. Also, be here Tuesday, 8 o'clock. We'll be back with a live stream and back to sort of the standard, talk through design. Actually, the stream that I streamed that didn't actually air, I thought was kind of a cool project. So we sort of finished Stinger 1.5 last week. Uh, this week I started sort of a concept for Stinger 2. So, in I know that some of the students that may watch this are going to be part of that development group, and it might be worth giving them a little cheater head start. You know what I mean? So, anyway, again, thanks for watching. Hopefully, this was helpful, and we'll see you back next time.